Welcome to this session in which we are going to learn how to construct classification random forest. So far we have built classification decision trees using C-tree and rparty. Decision trees are easy to elaborate and interpret. Random forests, on the other hand, leverage on computational power and use a bagging method in which they take random sets from the dataset and create decision trees with random subsets of the variables. Therefore, the classification is not defined a probability assigned by an individual tree, but by the vote of the random trees that make up the forest. So we are here in R, and the first thing that we are going to do is to install the random forest package. So we are going to write install.packages random forest. I'm not going to press enter, but if you haven't installed this package, you have to press enter. I'm going to put the package on the library. Press enter. So now we have the random forest in our library. Before creating the model, let's refresh two important parameters of the random forest model. The first parameter is importance, which is a measure of how much the elimination of a variable decreases the precision, and vice versa, how much the precision increases when including a variable. The second parameter is proximity, and this parameter measures the closeness between pairs of cases. The proximities are calculated for each pair of sample points. If two cases occupy the same terminal node through a tree, their proximity increases by 1. After running the model with all the trees, the proximities are normalized by dividing them by the number of trees. Proximities are used to replace missing data, locate outliers, and determine low-dimensional points of the data. So let's create our first random forest model. We will write a random forest model equals to the function random forest of the package random forest. And this function has 5 parameters. The first one will be the formula. So the formula that we are going to use is the dependent variable, retain in 2020 equals, and we use the symbol alt plus 126, and we set all the variables minus group state. And why we are not including group state? You could include it, actually you could try to include this variable, but as with the C-tree algorithm, we are going to remove the group state variable, given that it has 54 levels, which is too much for the random forest package. Since we already have the aggregated variable regions, then I'm going to remove this variable from the model. If you consider that this variable is important and you don't want to remove it from the model, you could create a variable that takes into account those states with most sales. Let's say the first 10 or 15 states, and then add all the other states in the variable others, or in the class others. So the next parameter, I will press Shift Enter, will be the name of the data, which is the data training. We are creating the model using the data training, and then we will predict use this model to predict the data with the dataset testing. The other two parameters, well, actually there are 6 parameters. So the third and fourth parameters will be the ones that we explained at the beginning of the session: importance and proximity. So we are telling to the random forest package and to R that we want that it takes into account the parameter importance, so equals to true, and that we want that it takes into account the parameter proximity, which equals to true. Then we will set the cutoff value, and as you can see, we are not setting just one number but 2. So we are going to set 2 numbers because there are 2 classes in our dataset, the class 1 and the class 0. By default, the cutoff value is set at 0.5. That is, it is necessary that half of the trees vote yes or no, depending on the class, so that the predicted value of an observation is assigned as 1 or as a 0. If we had an utility function, we could tune these parameters. As we don't have it, we will set it as 0.5. Note that we set as many cutoff values as classes we have in our dataset. So as our variable or retain in 2020 can get two values, 0 or 1, then we are using 2 cutoff values. And finally, the 6th parameter will be the type of the random forest. We are elaborating a classification random forest, so we will write classification. And we close the parentheses. I press enter, and this will take some minutes. After about 1 or 2 minutes, R has finished to create the model. Now let's print and plot the model. We're going to write print rf.model. We press enter, and we can see the model that R has created. It's a classification model. If you don't set the number of trees by default, it will create a model with 500 trees. The number of variables tried at each split was 7, and the error is about 20%. And you can see the class errors here in this confusion matrix. We can also plot this model. Plot.rf.model. And you can see, well, we are plotting the errors of the model. And something really interesting to observe is that after about 60 trees, we can see that here is about 50, a little more than 50, about 60 trees, the models have an error of approximately 0.2 or 20%, the one that is presented over here. This implies that no matter how many trees we use in the forest, we will no longer reduce the error. So after about 60 trees, you cannot reduce the error anymore. Now we can print the importance of the variables, or print which variables have more importance. So let's, I'm going to open this because we need some more space here. I'm going to clean the screen and write importance, I open parentheses, rf model. And we can observe the importance of each one of the variables in the model, both due to the accuracy, the mean decreased accuracy, and also the impurity associated, the mean decreased Gini impurity with them. Now let's plot this to observe it much better. I'm going now to close this because now I need the plot area. I'm going to write var imp plot rf model. Press enter, and now you can observe here the variables, or the importance of the variables measured as the mean decrease accuracy, and the impurity, the mean decrease Gini. You can see that according to the mean decrease accuracy, the most important variables is non-annual, new existing, single grade, FPP, which was full price participant, or full participant price, something like that, and from grade. And in the other hand, the most important variables when we take into account impurity is non-annual. We can see that in both cases this is the most important variable in our model. Income level, single grade, which is also the third more important variable in the mean decrease accuracy, according to the mean decrease accuracy. New existing is fourth, and you can see here that it was the second one according to the mean decrease in accuracy. And from grade, which is also the fifth more important variable according to the two, I would say, metrics. In the next session, we will use the model that we just built to make the predictions in the testing dataset. Thanks for watching.